So you're good with all the topics which we covered, right?
Yes.
Vector spaces, Euclidean spaces,
Yes. Yes.
subspaces, and all everything, right?
Yes.
Good. So today we're gonna be
Yeah.
discussing.
But one thing I wanted to ask about the normed space and the before metric space. So these two are functions which will. So the normed space is for to calculate the distance. The other one is to calculate the length
Uh,
from the Euclidean space, right?
exactly. So this all the things what we did, right? We did on Rn means a Euclidean space of what you call n equal to 1, 2, 3, 4, or 5. So when that is into picture, that is called Euclidean space. So whenever we use this metric space on a function d, then this is always a distance function. Okay.
So metric
So
space is always a distance function.
yeah, we use metric space, and this is always a distance function, which we will see during the calculations and all. So here it's like
Okay.
we normally we have the clarity around the exact definition of the metric. See, it says that so we have a metric space represented as xd, which means that we have a set x, okay, which you can see in the diagram in the blue color. Okay, it's like we also have this set coupled with a metric, that is the function d, which takes 2 points from set x and map it to a real number. That is x into x. That is, it will be a real number.
Okay. Okay. Got it. Got it. Yeah.
Yeah. So these things is like, I mean, if you have just this, what you call this equation, right? Not equation, kind of a representation, right? Then that is more than
Yeah.
enough. Just you need to simply explain it. If you are able to explain it, you are at least above 70% of the machine learners or the data scientists.
Okay. Okay.
Because normally you will
Yep.
see
Yep.
that that people will say that, hey, I want to learn machine learning, want to learn what machine learning, but when it comes of learning maths, right,
Yeah.
they will be two step back.
Yeah.
Yeah, these things are actually very much prone to the interviewers, right? They do really understand, okay, that, I mean, see how logical the guy is. So it's pretty obvious, Santosh, even though you are kind of average in the programming or below average in the programming, right? But if you
Mhm.
can at least write the logic right, that what formulas you have to use and which distance formula you have to use for this algorithm, then
Okay.
that is very much satisfying and that is very much impressive during the interview time.
Got it. Got it. Yeah. True.
So the next one, we deal with these all things. Yeah. So we have to start. I gave a initial introduction to this slide yesterday itself. If you can kind of explain me, if you remember what I told in the product space, you know, it's got a new topic.
Inner
If you
products.
can, yeah, you could try splitting the terms and try to explain if you can.
Okay. Inner product is a function such that it is a dot product of two vectors, which gives the real number, right?
See, whenever you say kind of it gives a real number, right? Obviously, your intention is correct, okay, but the definition is
Okay.
partially correct, okay. When you say this arrow, right, it means that it belongs to real number, okay. As I told you, right, means obviously that gives a real number, correct. Hello, can you hear me?
Yeah, I can hear. Yeah. Yeah.
Yeah. So when
Following.
you see these two dots, every time you search that, and when you to see this arrow, right, every time say that belongs to a real number.
Okay. 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 Okay.
Yeah. So we can say that that inner product space is basically just a vector space that is a cube with an inner product. An example of inner product can be thought of dot product of two vectors, say u and v, that we can write as u comma b. Here they have written x into x, right, y into x. That only we can write, suppose u comma v, and this sign, right, every time don't
Mhm.
forget this sign. This only signifies the inner product.
Okay.
Okay,
Okay.
this is what it signifies, the
So inner
inner.
product is not always a dot product.
No, obviously it's not always a dot product. It can be a scalar, it can be a vector. I mean, it can be a scalar product.
Okay. 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 Okay.
Yeah.
Okay.
So it is like denoted by this type of notation what we have seen. In order to be a inner product space, right? Obviously, it has again to satisfy some of the parameters, some of the properties. Okay,
Hmm.
and those three properties are this one, and this obviously we have discussed yesterday, right? You explained me
Hmm.
that, I mean, if obviously if you're
Yeah.
taking 2 points from a space x and y, then obviously the distance will be greater than zero. But
Greater
if
than
you
zero.
are
Yeah.
taking same points, right? Obviously it will be equal to zero. It shows that it holds equality if only x equal to zero and all. Now next is the linearity. Every time we study this, and then this xy will be obviously the distance between the point xy will always be equal to the distance between point yx, right?
Hmm.
Yeah.
Yep.
So yeah, now the next one. Hmm. So the
Pythagoras
next,
theorem.
yeah, it deals with a theorem, which we have probably been studying since our childhood, right?
Yeah.
Yeah, but let's talk in a more mature way here. Which says that if x is perpendicular to y, then the square norm of x plus y is equal to the sum of norm of x and sum of norm of y. Means this one. Okay,
Hmm.
when x is perpendicular to y, then the square of norm of x plus y as a whole will always be equal to the square of sum of square of individual sum of square of norm of individual x plus square of norm of individual y. Correct?
Hmm. Yes. Yes.
Yeah. So on basis of the properties what we studied in the last slide, right? So now you are going to explain me this line. I mean, from here, there is a proof of this, that obviously proof exists. You can use it uh, by the diagram, like saying that if you have a triangle of side ABC, then you could try proving it. But I wish that
Okay.
since this is a one-liner proof, starting from here, if you
Okay.
can
Okay.
explain me.
Okay. So.
Also, one more thing. Be sure that we are using these three properties here, okay, in order to prove that.
Okay. Okay. Sure. Sure.
Hmm.
So here, sum of square of two vectors
Hmm.
is equal to, I mean, that's a inner product of two elements, right? So
Yeah. So
x,
when we have this double line, right? I mean, this
that's a
line,
norm.
it's a norm. Yeah. So we'll say
Yeah.
that sum of.
Sum of normed square
Correct.
uh, equal to, I mean, on the right hand side, x into x is zero. The dot product of a same vector will be zero.
First, yeah.
First, yeah,
So
the first one. And the
correct. No, no.
last one, y comma y is also zero. So we are left
Okay.
with the inner two.
Uh,
So the inner product of y comma x is equal to inner product of x comma y. So we can assume as same,
hmm.
right?
So before that, did we get why this x y equals to zero?
No, actually, I mean they are perpendicular. If they are perpendicular, then it is zero. Actually, I mean,
I think you guessed it
I'm
wrong.
not sure. I
You
mean, why it is perpendicular and why the perpendicularity came here. That's what
uh,
I'm going to ask actually.
okay. Not an issue. Not an issue. Uh,
So,
See, as I told you, right, that we will be using the properties of inner normed space that we used in our last slide, right? So when x is perpendicular to y, I'll explain you this how this x comma y equals to zero. Okay,
okay.
and yeah, before that, let me explain this. So this is the LHS, right, left hand side, x plus y normed whole square, correct?
Mm-hmm.
So how can we write about that? Okay, now suppose it's like we can write this as x plus y comma x plus y, like inner product of x plus y comma x plus y, right? We can write this, correct?
Yes, yes,
Correct. So now
yes.
first take this x and multiply with this. I mean this value. Suppose this is u and this is v. Okay. So now x into x.
X into x, x into, yeah.
Correct. Now again it is this y is multiplied by this one, correct? Now y
Yes,
into
correct.
x, that is
X, y, x.
yx, correct? And then again
Yeah,
this one x into y for this one, right? This is multiplied with this again, and then this with this, correct? Y into y, then x into y. Got it, right?
got it, got it.
Yeah. So till here we are clear.
Hmm.
Yeah. So now let me
But dot product of x and x is zero, right?
well, let me explain you how it goes. If dot product of x and x is zero or what, or it is zero or not. Okay. One second. Let me open note. Bend. You can see my pen, right?
Yes.
Yeah. So one second. So any idea like I think I have not told this though. I mean, it's like
Mm-hmm.
in the trigonometry, you might have studied something like what is the exact definition of a dot product. Normally, we'll say x into y, but normally how it goes is like x y. It's like you have some. Let me explain you this way. Suppose okay, this is an x vector, correct?
Mm-hmm. Yeah.
One second, it has become somewhat better. This is an x vector, and then this is a y. Okay, and this will be angle theta. So what we say the dot product, means what we say the dot product of x and y, what it is equal to, it's equals to xy cos theta. Okay.
Oh.
So now, if suppose this theta is kind of, it looks like it is 30 degree, right? Suppose. Okay. And then we are increasing the theta, suppose. I mean, this is again our x and this is now our y. This is our x vector. Okay. And this now theta we have 45 degree, correct?
Mm.
So xy will be cos 45
45.
degree. Here it will be cos how much? 30 degree,
30
right?
degrees. Yes, yes.
So now here in our case in the Pythagoras theorem, we have theta equals to how much? 90 degree, right?
Yes, yes.
So xy cos 90 degree. And what is the value of 90 degree? It is always 0.
0.
Yeah, because sine 90 is 1, so cos 90 will be 0. And so obviously this value will be finally be 0, right? If this is 0,
0.
then this is entirely 0. Correct.
So x comma y will be 0.
Correct, yeah.
Okay, okay. Got it, got it.
Got it, right? And
Got it, got
actually
it.
there is a trick, so obviously that how did we arrive to this formula. Let me open a new print. Can you say this or you're still saying that older
No, no,
one?
I can see the new pen.
You can see, right? Yeah.
Yeah.
The thing is, this I never knew that before I came to know. I think around 7 to 8 months back. This Zoom,
Mm-hmm.
right? It is very much specific and it's very much, I mean, kind of it holds your privacy. Okay. When you open a file type of suppose Excel, right? And if you by
Mm-hmm.
mistake you're opening your email or you're opening your TextPad, Notepad plus plus, right?
Mm-hmm.
And if you're sharing the screen, right, it will not be shown to the user. I mean, it will not
Oh.
be shown. Yeah, it is. But
Oh.
again, the thing is that we are using here zoom.us.com, right? The thing is that in my company that we use Dell.zoom, okay? It means obviously that is enterprise version.
Yeah,
That
enterprise version, right? That
yeah,
will
that
have a
has
lot
I
of
mean
features.
and that has also
Yes,
so
yes.
many kind of dependencies and so many features, man.
Yeah, yeah, yeah. Enterprise version will have.
Okay, so I was just I'm just trying to let you know that how do we calculate uh,
Dot
value of
product.
dot product, that when we use obviously cos theta sin theta and all. So before that, suppose if we have a triangle here, so let me first write it that there is a kind of some trick, which we studied I think class 11th or 12th.
Mm-hmm.
So I'll explain you first. Let me write it down. Okay, now you can see this, right? S means sine theta. Okay,
Yeah.
sine theta means perpendicular by hypotenuse. So what is perpendicular? Perpendicular will always be, the side opposite to this theta. So this is my perpendicular this time. Okay,
Mm.
perpendicular, and this is hypotenuse. You must be knowing.
Yeah.
And now where this theta is being holded, right? This one. Then this is our base.
Base. Yeah.
Yeah, this is our base. Got it?
Got it.
Yeah. So in order, I mean, not to be getting confused with how this formula comes and how to learn and not learn and that. Okay, first let me explain you just one liner. It's like S means sine theta equals to P by H means perpendicular by hypotenuse. Okay, and cos theta C. Okay, cos theta is C and it's called to B by H. That is called base by hypotenuse. This is base and this is hypotenuse. And T is the tan theta. This is called perpendicular by base. Okay. So now, what is the trick to learn this? It's a simple statement, simple phrase, which people use to give us as a trick. It's like we can
Mhm.
say, like some people have curly black hair tightly pulled back. Got it?
Got it. Got it.
Yeah. So if you can make a note of it, it's like it will be very much
Yeah,
useful to you.
I'm writing out.
Yeah. Some people have curly black hair tightly pulled back.
Black hair, tightly pulled back. Yeah.
Got it, right?
Got it. Got it.
Yeah. So in this case now, if we are focusing to the dot product of this, that is called cos theta, correct? So we can say that
Yes.
cos theta equals to base by hypotenuse. Okay. Now what is my base? Base is AB, right? So let's assume this AB as a x vector, correct?
Okay.
And this we assume that this one AC, that is perpendicular as a y vector. Okay, so in this case what it will be, b by base by hypotenuse. Okay, and this one is like this one will be what, one second.
Cost it down.
uh, the diagram has become too dirty, man. The thing is that, in order to draw this I have to use my fingers on my touch screen and my fingers are
Uh-huh.
fat, so it covers that. Anyway, I mean, we can similarly, right? I mean, if we put the value of the base here and the height here, then we can calculate the cos theta, right?
Cost it down.
Yeah. So similarly, it's like suppose we have to calculate the base, then it will be like h cos theta, that is hypotenuse cos theta. If we have to calculate the hypotenuse, then it will be like base by cos theta, right? And this theta can
Mm.
be anything, right? 30 degree, 40 degree, 45 degree, 90 degree, and there is a
Yes.
chart. There is a chart for the value against each, right? Cos 30, cos 45, cos 90.
Yeah. Yeah.
Yeah, so this actually might be useful sometimes, but let's skip this one, right? I mean, this formula handy. I mean, this
Okay.
logic,
Okay.
yeah, this will be very much useful.
Okay.
So now let us come back to the original business. Hmm.
So the dot product of two vectors is always
Cos theta.
xy cos theta.
I mean,
I
yeah,
mean between two vectors.
correct, yeah.
Okay.
And when so it is like any what you call any component to take, right? X and Y, or it's like U, V vector, whatever. So we'll say that the dot product of this two vectors U and V is like UV cos theta.
Okay.
Got it?
Got it. Got it.
Yeah. So that is why now I had asked you that if you can explain me this x y equal to 0. So here we can see that x into y
Is always zero. Yeah.
always
Because
0,
of the
right?
perpendicularity.
So we'll have x into x x squared. So this is, we proved it. And then again y into y is called y square. Correct?
Got it. Got it.
Because this y comma y is called what? Y comma y is the inner product of 2 points from a space. And here the 2 points what we were taking is y comma y.
Y comma.
Here, see, it's
It's
like
always
v
greater
comma
than,
v.
yeah.
Yeah, correct, right? So x comma
Correct. Correct.
x. Yeah. So we have proved out this Pythagoras theorem, correct?
Yes. Yes.
So you got it, right?
Got it. Got it. Got it.
Yeah. So so now the next topic is, it's Cauchy-Schwarz inequality. So in Pythagoras theorem, what we use? We use dot product, right? So, but in here in this Cauchy squares inequality, we will be using cross product as well as dot product. Okay,
Cross
so
product and dot product.
dot product, yeah. Mm. By the way,
So
what
cross
is?
product is nothing but a regular product, or
You tell me. Obviously, I wish that all the questions should be answered by you.
yeah. So I don't remember actually. And cross product is, yeah, that's element wise product.
See, the thing is, I told you, right? I mean, there are two top products which we use on a vector. One is a dot product, and other is a cross product. Okay. So whenever we have a vector, suppose you have a vector A and B, then the cross product. Here, what we saw in the dot product, right? We say that if you have a vector x and y, then we'll have the cross product as x y cos theta, right?
Cos
But
theta, yeah, that is
yeah,
dot
but
product.
there is just one difference here. The cross product is like a into v sine theta, means x into y sine theta. Okay,
Oh,
so for the diagram, what we saw that x vector was on the base side and y on the perpendicular side. If we take a dot product, it will be xy cos theta, and if we want to take a cross product, it will have xy sine theta.
sine theta. So these
Yeah.
are all only for vectors, not for matrix or anything like that.
No, 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 no. So it's pretty obvious, you know. So vector when we call, right. So vector can be obviously with a space when r equals to rn equals to n equals to 2, where n equals to 3, 4, and n equals to infinity, n equals to 1000 also, right. So when we talk about a vector space, right? Okay. So obviously we are talking about two elements also. We are talking about three elements also. And when it comes to machine learning, right? Obviously we are talking about more than 500 elements,
Hmm.
meaning when we kind of we have okay, I'll explain this, okay, in the next few of the slides, that how do we relate, you know, the some of the terms with a vector, okay, in our real life example of machine learning, that how this vector comes into picture, that why we are studying vector so far for you it must be like entirely maths, right? We are studying maths.
Hmm.
Yeah, so maybe in the after 3/4 slide, I think I have a coverage of that. I'll explain
Okay.
you uh, that how actually this vector space comes into picture for a real life example. Okay, I'll cite one of the example of my local project. You know what we are doing,
Okay.
so how it goes and those things.
Okay.
Okay, so you know, as I explained you that the cross product is always AB xy sine theta or AB sine theta, or if you have two vectors u and v, it will be represented at UV sine theta. But one second, have I covered? Yeah. So let me use again the Notepad plus plus. So how to be Notepad. Let me use the pen.
Okay.
Yeah, you can see this, right?
Yeah, I can see the point.
Yeah. So now we need to understand that how this cross product of two vectors look like. So let us assume some vector like A and some vector B, right? Okay.
Mm-hmm.
So let me draw this first. So only one thing, you know, what we have to understand here is like, you know, in the cross product, we do not get a vector, and sorry, in the dot product, we do not get a vector, but in the cross product, we always get a vector with a new direction. Okay. So now let us
Oh,
assume, okay, this is the theta, and this is your A vector, and this is your V vector. So whenever you put an arrow over A, I mean the vector component, right, this becomes a vector with a direction. Got it?
got it. Got it.
Yeah. So now, very important thing. We are trying to find, our plan is to find the cross product of A and B. If you remember something we studied in class 11,
Mm-hmm.
let's recall that, you know, that was called right hand thumb rule. Remember? You remember this name, right? In SC Verma, we have to study this right hand thumb rule. You know, if you have we studied in the chapter of electric field. Uh,
I don't remember.
okay,
Forgot
now then,
everything.
Not an issue, not an issue. Anyway, it's like I think more than 8 years, 10 years, right? Something.
Yeah, yeah,
Yeah, not an issue. Mm.
yeah.
Okay, so what does it says? You know that if you have two vectors, say A and B, having their own direction, okay, on an angle theta, then what is the cross product? Is that using the right hand thumb rule? It says that its cross product will be somewhat this side, and assume that all the 3 points, right, they are on different plane. One is x-axis, y-axis, and z-axis. Got it?
Okay.
So this is your A cross B. Okay, this is your A cross B, and this is having a direction this side. Means,
Oh,
see, what was the right hand thumb rule? So 1 second, let me open something, a diagram for you on the Google. So that right hand thumb rule. Hmm. Hmm.
hmm.
So can you see this?
Oh, yeah,
Yeah. Now try to relate on what I had explained you right now.
yeah,
So
yeah.
we had this vector A at this angle, right? V. Now this is his right hand. See clearly,
Yep,
it is
yep.
right hand or left hand. It's right hand, right?
That's right hand.
Correct. So now it says that if two vectors A vector V are aligned with an angle theta, then their cross product will be given by this thumb. Okay. So okay,
Okay,
the direction of this cross product will be at this position, at this direction. Got it?
okay.
Clear, right?
Yeah, with left hand also it is showing same, right?
Uh, the thing is that you are right, but this when this right hand thumb rule it was given, right, it was being given for electricity, for electric fields, for the magnetic fields. Okay, so it's like
Okay.
yeah. So when you are using your left hand thumb rule, right, the middle finger where it goes, right, it actually depicts a negative electric field which does not exist. So that is why he had used to explain it to your right hand thumb rule. So it's like, okay, when you have to, if you have two vectors on forefinger, that is A, and the middle finger B, then the
Mm-hmm.
cross product will be given by AB sine theta. It is simply to kind of make the user understand, right?
Yeah, yeah,
It's as simple as that.
yeah.
Yeah. So coming back to, we were on 10th, right? Yeah. Hmm. Okay.
So,
So now we are clear that this is our cross product, correct?
mm,
A cross B. So, but the final formula, what it is like. So now let us just complete this kind of a parallelogram. What it follows.
mm-hmm.
A cross B something. So B, when we take this, it is called a mod, right? Okay. So now the finally, how we will represent this cross product, right? So we will represent it as in form of a norm. Okay. Since we have studied, we know what is a norm now. This is equals to norm of A, got it?
Mm-hmm.
Into norm of B, got it? And
Mm-hmm.
here we'll have sine theta.
Cross product.
Yeah. So it's like, so the inner product of, you can say that inner product, we are using a scalar product this time. It is like kind of scalar product of vector A and scalar product of vector B, which comes out to be sine theta. Okay.
So this
So
is the definition for the norm of the cross product.
not norm
Or
of the cross product. It is simple. Definition of a cross product. We are just
yeah,
showing it here using norm. Okay. We can also show it using modulus. This one we say right. That x cross y mod of this.
yeah.
So, yeah. So normally till now, what we have studied, we have also seen the norm and we have seen the mod, right? But we can represent using any of those.
Any, okay, okay, okay.
Got it, right?
Got it, got it.
Yeah. So again, this how this value of sine theta varies is like, I mean, sine theta, if theta equals to 0, right? This is 0, correct? So this entire value will be 0.
Hmm.
So again, it's like if theta equals to 90 degree, then 90 equals sine 90 is what? Sine 90 is
One,
1. Yeah. So this value will become 1,
one.
and then again this norm of a cross b will equal to be norm of individual norm of a into individual norm of b.
Individual number B. Yeah,
Hmm. So that's it. Got it, right?
got it, got it.
Yeah. So coming back to the slide. Yeah. So what this property it was talking about, this inequality property which says that modulus of